Alright, welcome back to another video. So today we'll be going through the 2021 HSC Mathematics Standard 2 paper. So just before we do get into it, one thing to make sure that you are aware of is that you have the 10 minutes reading time. So make sure you read through the exam beforehand, and then you only have 2.5 hours to actually complete 100 marks worth of questions. So make sure that you only allow about 90 seconds per question. Alright, let's get into it. So, question one, starting off fairly straightforward here. So which of the following shapes has the largest perimeter? Let's just go through them all and quickly check. So simple square, so 8, 8, 8, and 8, so that'll end up being 32. 3, 11, and 11 and 3, so that one's going to have 28 centimeters as a perimeter. Equilateral triangle here, so 10, 10, 10. So it's going to be 30 centimeters for our perimeter there. And over here we've got 3 and 9, so that's 12, plus 4, 16, plus another 4, that's going to be 20. So clearly our choice here is going to be A. There we are. Alright, so question 2. Consider the network diagram below. So it asks us, what is the sum of the degrees of all of the vertices in this network? So a quick way to count up the degrees for a vertex is to quickly just put a circle around it and then just count how many lines cross through that circle. So for B, we've got 3. For A, we've got 1, 2, 3, 4. For C, we've got, again, 1, 2, 3, 4. For D, we've got 2. And for E, we've got 3. So adding those all up, let's see what we get. So we've got 4, 4, 2, so that's 10. 3, 3, it's going to give us 16. Okay, question 3. So the stem and leaf plot shows the number of goals scored by a team in each of 10 netball games. So it asks us, what is the mode of this data set? So just a quick reminder, so the mode is a score that occurs the most frequently. So if we have a quick look through, well, we see that 5 doesn't even occur, 18 doesn't occur, 25, that certainly does occur, and that occurs twice, and 29 only occurs once. So clearly our answer is going to be C, 25. Moving on, question D. 3 years ago, an appliance was valued at $2,467. Its value has depreciated by 15% each year. Based on the declining balance method, what is its salvage value today to the nearest dollar? Okay, so let's quickly remember our formula for that one. So that normally follows that S, the salvage price, is equal to P, what it was initially valued at, multiplied by 1 minus the rate. And then that is to the power of n, or t, depending on what you prefer, which just represents the number of years. Okay, so let's substitute some of these values in and let's see what we get. So S is going to be equal to 2,467 times by 1 minus, so 15%. So I'm going to write that as 0.15, and then that bracket is to the power of 3 for the 3 years. Okay, and when we put that all into our calculator, we find that this appliance is now going to be worth $1,515. Okay, question 5. So, Peter currently earns $21.50 per hour. His hourly wage will increase by 2.1% compounded each year for the next 4 years. What will his hourly wage be after 4 years? Okay, so a quick compound interest question. So just a quick reminder, as our formula for that one is A equals P outside the brackets, 1 plus R, all to the power of n. Okay, so having a quick look at our question, well, we can see that we've got P is our initial wage of $21.50. So let's start going through and filling out what we've got. So $21.50 times by, we've got 1 plus, now the rate of 2.1%, we need to write that as a decimal, so that's going to be 0.021. And then that is all to the power of 4. Okay, so to write this out very, very simply, we can just put it as 21.5 times by 1.021 to the power of 4. And then so we have a quick look at our answers, and we see that that one's going to be B. Okay, going to question 6 now. So suppose that A equals B over 7, where B equals 22. So what is the value of A correct to 3 significant figures? Okay, so let's quickly put that into our calculator and let's see what we get. So when we see that in our calculator, it will come out as 3.1428 5, 7. So I've clearly given us far too many decimals. But let's have a quick chat about significant figures. So significant figures always start from the first non-zero number. So here that's very clearly just going to be that 3. And then we just continue counting until we get to a total of 3 figures. So it's going to be 3, 1, and 4. But now we need to check, will it remain as a 4? So we look at the digit after, and that's a 2. So we won't round it up, we'll just leave it as it is. So then our answer will be 3.14, or in other words, A. Okay, moving on to question 7. The number of downloads of a song on each of 20 consecutive days is shown in the following graph. Okay, so we can see that as the days go by, the number of downloads each day increases up until day 10, and then it starts to decrease after that. So which of the following graphs best shows the cumulative number of downloads up to and including each day? Okay, so we're looking at cumulative frequency here. So it's very, very important for us to note first, before we even look at any of the options, is to look at the trend of this graph. So we see that it has a bit of a slow start, and then there's a lot of downloads towards the middle. And then again, it starts decreasing and kind of slows off towards day 20. So if we now look at some of our different options, let's see what we've got. So A, it kind of just steadily increases before slowing down towards the end, so maybe not the most accurate. B starts off very, very slow, but then it would be having a relatively significant amount of downloads towards the end here. Now C, what we notice here is that it starts off slow, and then there's some significant increases towards the middle, and then it also starts slowing down towards the end. And if we think about it, that exactly matches what we saw in this problem up above. So our answer for question 7 is going to be C. Okay, moving on to question 8. So on a test, Zach's mark corresponded to a Z-score of 2. The test scores had a mean of 63 and a standard deviation of 8. So what was Zach's actual mark on the test? Okay, so we need to remember our Z-score formula, which is as follows. So Z equals x minus mu, the mean, over sigma, our standard deviation. Okay, so reading through the question, we know that Z is equal to 2. So the test scores had a mean of 63. Okay, so we'll put that in there for now. And the standard deviation of 8. All right, fantastic. So now what we need to do is just simply solve for x. So to do that, multiply both sides by 8, and then we're left with 16 equals x minus 63. And we can just add the 63 to both sides, and then we find that x equals 79. And that's going to be option D. Okay, question 9. A student is thinking of a number. Let the number be x. When the student subtracts 8 from this number and multiplies the result by 3, the answer is 2 more than x. So which equation can be used to find x? So let's not bother reading through those options. Let's just quickly figure this one out for ourselves. So let the number be x. When the student subtracts 8 from this number, okay, so right off the bat, we are taking 8 away from this number, x, and multiplies the result by 3. So that means now we need to put brackets around that and times it by 3. So I'm just going to put that 3 out the front there. The answer is 2 more than x. Okay, so 2 more than x, that's just another way of saying x plus 2. Okay, so let's quickly look through our different options here and let's see if any match. And well, we see that option C is a perfect match. So there we are. That's our answer for question 9. Question 10. Which of the following best represents the graph of y equals 10 bracket 0.8 close bracket to the power of x? So there are two things that we need to recognize here. So firstly, our y-intercept. Will it be at 10 or will it be at 8? So to figure out our y-intercept, we need to let x equal 0. And so what that would look like then is y equal 10 times 0.8 all to the power of 0. And well, we see that anything to the power of 0 can just simply be rewritten as a 1. And so then we can see that our y-intercept is simply going to be equal to a 10. So now we can eliminate options B and options D. Okay, so it's now between either A and C. So to figure it out from here, well, we need to determine, will it be increasing, as we see in option C, or will it be decreasing, as we see in option A? And so if we remember from studying exponentials, then if this number here, our base, is less than 1, then it will decrease. If it's greater than 1, then it will increase. Otherwise, what you could do, if you are not too sure about that, you could just go through and test a few different values of x and then see the trend. Is it increasing? Is it decreasing? You can decide from there. Okay, question 11. There are 8 chocolates in a box, 3 have peppermint centers, and 5 have caramel centers. So Kim randomly chooses a chocolate from the box and eats it. Sam then randomly chooses and eats one of the remaining chocolates. A partially completed probability tree is shown. Okay, so first thing that we should do is finish this probability tree off. So the first branch is going to be from Kim, and then the second branch is going to be from Sam. Alright, so assuming that Kim eats the peppermint chocolate, then that means there are only going to be 2 out of 7 remaining for Sam to choose from. However, we'll still have 5 out of the total 7 of the caramel. On the other hand, if Kim has a caramel chocolate, and then Sam randomly chooses one, he will have a 3 out of 7 chance of choosing a peppermint, and a 4 out of 7 chance of choosing a caramel. Okay, so now we can actually look at the question. So it asks us, what is the probability that Kim and Sam choose chocolates with different centers? Okay, so what I'd recommend doing here is to go through and sort of either highlight or underline or go through and color in the path that you'll be looking at. So we can have a peppermint caramel path or a caramel peppermint path. Oops, that's a bit dodgy, but that's okay. There we are, a bit better. So what we need to do now is we need to look at the 2 different probabilities of each individual path here. So for the peppermint caramel path, we'll have 3 on 8 times by 5 over 7. And then for the caramel peppermint path, we'll have 5 over 8 times by 3 over 7. So what we need to do is quickly see what those will multiply out to give us. So 3 times 5, that's 15, and 8 times 7, that will give us 56. And then we see the exact same thing for our second product over here, of 15 over 56. Okay, so our last step here to compute the total probability is simply to add these two. So then we'll get 30 over 56, and we notice that that is divisible by 2, so we can simplify it as 15 over 28. And then we see that our final option is D, and that will be our solution to question 11. Okay, going to question 12 now. So a block of land is represented by the shaded region on the number plane, as we can see. All measurements are shown in kilometers. So which of the following is the approximation for the area of this block of land in square kilometers using 2 applications of the trapezoidal rule? Okay, so using 2 applications, so we obviously want to go from 0 to 6, and then from 6 to 12 over here. So remembering our trapezoidal rule as A equals H over 2 times by A plus B. Sometimes people will write that as times by X plus Y, but I think A plus B is a bit more standard convention. Okay, so let's go through and see what we'll end up with. So A will be equal to, so the H, what we need to do is we need to think about this trapezoid as it's on its side at the moment. So our height is actually going to be from 0 to 6, so it's going to be 6 on 2. And then A and B, those are going to be the 2 different bases. So we can see going over here and over here. So then we'll have 1.2 plus 2. So that's our first application of the trapezoidal rule. Okay, for our second application of the trapezoidal rule, again, now our height will be going from 6 up to 12. So it'll still give us a height of 6 over 2. And then our A and B term will be slightly different. So now we're kind of working on the other side of this curved area here. So now we can say that it's 2 plus 1.4. Okay, so we can simplify that out and that will just end up being 3 times, let's see, what's 1.2 plus 2? That's 3.2 plus, and then it's going to be 3 outside of 3.4. Okay, so we can then quickly take out that factor of 3, and then it becomes 3 outside of 3.2 plus 3.4, and then if we compute that, we'll find that our answer is 19.8. So it's going to be option B. Okay, question 13. The time taken to clean a warehouse varies inversely with the number of cleaners employed. So it takes 8 cleaners 60 hours to clean a warehouse. All right, before we even look at the question, let's think about what's going on in this question. So the key here is that it's an inverse relationship. Many people would look at this problem and they would think maybe, the time is going to be, some sort of relationship to the number of cleaners. And that will give us a completely incorrect answer if we do that. So what we want to do is we want to say, let's have H as the amount of hours. A is going to be some constant, and then X is going to be the number of cleaners. So here, what we have is an inverse relationship, as we should remember from our study of reciprocal functions. All right, so our first mission should be to determine what this constant A actually is. So already given to us is that the fact that it takes us 8 cleaners, a total of 60 hours to clean the warehouse. So what we can do is we can say 60 equals A over 8. All right, so what does that mean? Well, that simply means that A is equal to 60 times by 8, which is of course equal to 480. All right, so now we know A, let's continue with the rest of this question. So that asks us, working at the same rate, how many hours would it take 10 cleaners to clean the same warehouse? Okay, so again, we look back at this original equation that we constructed, and all we're doing now is we're substituting in a different value of X, and we've just determined A. So now, our problem simply becomes H, the number of hours, is equal to 480, which is the A value that we've already determined, then divided by X, the number of cleaners, in this case 10. And that will give us 48 hours. So option B is the solution there. Okay, moving on to question 14. So we have a bearings diagram here, and it asks us, what is the true bearing of A from B? Okay, any bearings question, you always just want to make sure that you can draw the north lines from your two different bearing points. So we've got town A and town B, but what we need to do is we always need to construct it so that it looks like we've got the two parallel lines and a transversal line. So that way we can use properties that we probably would have learnt, I would imagine, in year 10, maybe even year 9. And so what we see is that, well, first of all, this is clearly a 90-degree angle here, which means that this total angle from A to B is going to be 90 plus 25, so that will be 115. And then what we know about the angle from here to here and the angle from here to here, let's call that theta, is that they are co-interior. So that means they must always add up to be 180. And so what that means is that we'll have theta equal to 180 minus 115. And so clearly that will give us theta equals 65 degrees. All right, and so now to determine our bearings, we need to work from that north line and go clockwise around that point B until we hit that line that directly joins points B and A. And so ordinarily a full revolution has 360 degrees, however now we are subtracting theta. So now we can say that the bearing will be equal to 360 degrees minus 65 degrees, or in other words, a bearing of 295 degrees, giving us option D. All right, moving on to our last multiple choice question. So question 15. So a total of 11,400 people entered a running race. The ratio of professional runners to amateurs was 3 to 16. All the professional runners completed the race while 600 of the amateurs did not complete the race. Okay, so with that information, let's see what we can get from that. So there's initially 11,400 people. And what we're going to do is we're going to break that into a ratio of 3 to 16. So what I like to do here is I like to count up how many different individual sections will there be. So there'll be 3 on the left-hand side and 16 on the right-hand side. So that means there's going to be essentially 19 different components. So what I'll do now is I'll say 11,400 divided by 19, and that will give us 600. So now what we see is that essentially the 3 to 16 is just a breakdown of 3 times 600 to 16 times 600. Okay, so that's simply what's been given to us right at the start of the question. And now let's look at what happens next. It says all the professional runners completed the race while 600 of the amateurs did not complete the race. For those who completed the race, what is the ratio in simplest form of professional runners to amateurs? Okay, so 600 amateurs did not complete the race, so that means we are going to be subtracting 600 from our amount of amateurs here. Or what we can do is we can just rewrite this ratio, because if we are deducting 600 from 16 lots of 600, well, we can just kind of write that as 15 lots of 600. And then if I want to simplify these ratios, well, they're both divisible by 600, so I'm going to take that out. And what we're left with is 3 to 15, and again, that can be divided through by 3, and that will give us a final ratio of 1 to 5, and that will give us option B. And that concludes the multiple choice section for this paper. On to the next section. Okay, so that brings us over to question 16 now. So, the volume V of a sphere is given by the formula V equals 4/3 pi r cubed, where r is the radius of the sphere. So we have a tank here that consists of the bottom half of a sphere of radius 2 meters as shown. So we just need to find the volume of that tank in cubic meters, correct to 1 decimal place. Okay, so first thing to note is that it's a half of a sphere. So that means our volume formula will just be taking a half of that. So let's write that out. So our volume formula for a half sphere is just going to be equal to 1/2 times by 4/3 pi r cubed. And now using the fact that r is equal to 2, well, we can substitute this all in and then just chuck it into our calculator. And we should get, I believe, 16.8 meters cubed. That's just some simple calculator work for you. All right, question 17. Let's get to it. So the 5-number summary of a data set is given. So we've got our lowest score, our lower quartile, our median, our upper quartile, and our highest score. So they've asked us, is 20 an outlier? And we need to justify our answer with calculations. Okay, so if something is going to be an outlier on a data set, and we're going to be defining that using our quartiles, what we need to consider is if it is above or below Q3 plus 1.5 times by the interquartile range. Okay, so clearly we're going to be working with the Q3 plus 1.5 IQR because 20 is clearly going to be an upper outlier if it is an outlier. If we were looking for a lower outlier, for example, if we were asked if 1 is if 1 is an outlier, then we would be testing for lower limits. So we would use Q1 minus 1.5 IQR. All right, so Q3 is equal to 10. Then we have plus 1.5, and the IQR is Q3 minus Q1, so 10 minus 4, so we've just got a 6 in there. Alright, so 10 plus 1.5 times 6, that's a 9 over there, so this will just become 19. Alright, cool. So, is 20 an outlier? We'll say yes, it is, since 20 is greater than 19. And that's all we need to write for that question there. Okay, moving on. The fuel consumption for a car is 6.7 litres per 100 kilometres. On a road trip, the car travels a distance of 1,560 kilometres and the fuel cost is $1.45 per litre. So what is the total fuel cost for this trip? Okay, so first thing we need to work out is how much fuel did they actually use on this trip. So we've travelled 1,500 and 60 kilometers. And we know that for every 100 kilometers, we use 6.7. So what I'm going to do is I'm just going to times this by that ratio that we were given at the start of the question. Okay, fantastic. And so after computing that, well, we can just simply divide that by 100, and then we'll have 15.6 times by 6.7. So I'll just leave it as that for now. So that's how many liters of fuel this person has used. So what we need to do now is multiply that by how much did it cost per liter. So we'll have 15.6 times 6.7, and now times by 1.45. Now, the reason that I haven't bothered working out every single little step of the way what every number will be is because that can waste a little bit of your time in an exam condition. So just to make sure that we know what we're doing, we can write it out simply in just different terms of multiplication, and then we'll get our final answer at the last step. So 15.6 times by 6.7 times by 1.45 will give us an answer of $151.55. There we are. Okay, question 19. So, Adam purchased some office furniture 5 years ago. It depreciated by $2,300 each year based on the straight line method of depreciation. The salvage value of the furniture is now $7,500. Find the initial value of the office furniture. Okay, so again, our salvage price formula using our straight line method is going to be S equals, sometimes we'll say V naught, sometimes P, it's completely up to you, minus D, the depreciation amount, and N, the number of years. Okay, so let's fill this in with the information we've been given. So Adam purchased some office furniture 5 years ago, so N equals 5. It depreciated by $2,300 each year. So that means that capital D is equal to 2,300. And the salvage value of the furniture is now 7,500. So we know that S equals 7,500. Alright, so now all we need to do is substitute all those in and then solve for V naught. So we can say that V naught is going to be equal to S plus dn, which in turn is going to be equal to 7,500 plus 5 times 2,300. Alright, and that will give us an answer of V naught equals $19,000. And that's our answer for question 19. Okay, question 20. It's a 3-marker, but it's actually pretty straightforward here. So, City A is in Sweden and is located at 58 degrees north, 16 degrees east. So we're going to quickly take note of the east-west for any time we see the locations represented in longitude and latitude. Always focus on the longitudinal section. So, City A is located at 16 east. Sydney is in Australia is located at 151 east. Okay. So Robert lives in Sydney and needs to give an online presentation to his colleagues in City A starting at 5 p.m. Thursday, local time in Sweden. So what time and day in Sydney should Robert start his presentation? Okay, so first of all we need to figure out the time difference. So what is the difference in longitude between Sydney and City A in Sweden? So we'll simply find the difference between the two longitudes. So 151 minus 16 is going to give us 135. And I should write that all in degrees. And we know that 15 degrees equals 1 hour. So what we'll do is we'll divide this through by 15, and that will be how many hours are represented by this time difference. And so that will give us a 9-hour time difference. Okay, so looking at it, we see that since Australia has the higher longitude, then we know that Sydney is going to be ahead in time from Sweden. So that means that when it's 5 p.m. on Thursday, Robert must be 9 hours ahead. So moving forward, we'll probably just add the 7 to get to Friday at 12 a.m. and then we add 2 more to make it the full 9. So we'd say Robert should start at 2 a.m. Friday. And that's all there is to it. Moving on. Okay. Julie invests $12,500 in a savings account. Interest is paid at a fixed monthly rate. At the end of each month, after the monthly interest is added, Julie makes a deposit of $500. So Julie has created a spreadsheet to show the activity in her savings account. The details for the first 6 months are shown. Okay, and what we need to do is, by finding the monthly rate of interest, complete the final row above for the 7th month. Alright, so what we should do is we should look at how much interest did we have given to us each month, and how does that relate to the amount at the beginning of the month? Just remembering, because we make that deposit after the interest has been paid. Okay, so a simple way to do that is to put the monthly interest. So let's just take the first month for the example here. So 18.75, and we can simply divide that by the initial amount in the account of 12,500. And when we do that, we should get an answer of 0.0015. And if I wanted to write that as a percentage, we simply times by 100, and then we have 0.15%. Okay, so that's our interest rate. So that's very, very important for us to know. All right, so what's the next step for us to complete? It just says complete the final row above for the 7th month. All right, so, well, the amount in the account at the end of each month, bit of a tongue twister there, is going to be the amount in the account at the beginning of the next month. So down here, for row 7, we know that the amount in the account at the beginning of month will be $15,000, I should say, $624.20. The monthly interest on that is going to be 0.15 times by that amount there of $15,624.20, which will give us a value of $23.44. So we'll chuck that in there now. And then we need to add on that 500 as well. And so when we add the $23.44 and the $500 to that amount, we'll find our final amount at the end of the month should be $16,147.64. And that concludes that question there. All right, moving on. Question 23. So the table shows income tax rates, as we should pretty much be used to these problems by now. So William has a gross annual salary of $84,000. He has allowable tax deductions of $900 for home office equipment and $474 for union fees. Okay, William must also pay a Medicare levy of 2% on his taxable income. All right, so just calculate the tax payable. So what we need to do first of all is deduct those two fees there. So now his total amount that can be taxed will be $84,000 minus the $900 for the home office equipment, and then minus the $474 for the union fees. Okay, and so once we do that, now we find that the total taxable income is actually going to be $82,626. All right, so what we need to do now is see which tax bracket he'll fall into. So clearly, he is between $45,000 and $120,000. So we know that the tax that he'll pay on his income is going to be $5,092 plus 32.5 cents for each dollar over 45,000. So the way that we'll write that out is plus 0.325, we'll write it in dollars, multiplied by 82,626 minus 45,000. And you can simply put that into your calculator, and what we'll get from that is $17,320.45. Okay, so we're almost there. All we need to do now is determine the Medicare levy. So the Medicare levy is just going to be 2% of the total taxable income. So 0.02 times by 82,626 will give us a value of $1,652.52. And so the total amount of tax that William should be paying is going to be the sum of these two amounts here. So then we'll say total tax is equal to $18,972.97. Don't forget to put your dollar sign there. Okay, moving on. So, network diagrams. So, question 23. So, the network diagram shows the travel times in minutes along roads connecting a number of different towns. And there's our network there. So it asks us to draw a minimum spanning tree for this network and determine its length. Alright, so there are a couple different ways that we can approach these problems. So you can use Prim's algorithm or Kruskal's algorithm. There are a few other more complicated algorithms that you might be familiar with, but I'm going to go ahead and use Kruskal's algorithm. So what that says is that we'll look at our network, and every time we see the lowest score or the lowest weighted edge, we'll go ahead and use that. So what I'm going to do is I'm just going to draw this up as we go. So it's going to go from minor town to Walter town. I'm just going to label that M and W, and that has a weight of 10. The next lowest weight on our network is 15 from Walter town to Park town. So we'll go ahead and put that in there. The next lowest is going to be the weight of 20 from Walltown to Fernville. So again, just going through slowly but surely. Alright, so that's up to 20. Now let's see what else do we have. We've got another 20 going from Minortown to Underwood. So we can put that in there. Minortown to Underwood, and that has a weight of 20. If we keep going, we find that there's a 25 going from Minortown to Kingsville. Are there any other 25s? Double check. Nope, I don't believe so. Alright, so then we have a 30 going from Kingsville to Queenstown. And I think we're almost there, so the only part that isn't connected yet is Citadel. So to connect Citadel to our network, all we need to do is just join the Citadel to Parktown. And that's just going to be given as such here. Alright, so I believe that's all of our different towns connected now. So now it asks us to find the length of the minimum spanning tree. So all we do is we go through and we work out the weights of each section and add them together. And oops, I've forgotten that 25 there, from Kingsville to Minortown. So what we'll want to do is just add all these numbers and see what we get. So 30 plus 20, 50, plus 25, 75, plus 10, 85, plus 15, 100, plus 40, plus 20. We'll get a total weight of 160. Alright, moving on. So it asks us now, so how long does it take to travel from Queenstown to Underwood using the fastest route? Alright, so Queenstown to Underwood. Let's look back at our original network. So we want to go from Queenstown to Underwood. So let's just start looking at the maps and see what we can do to get there. So Queenstown to Underwood, well, if I go up here, 30 plus 65, that doesn't seem very good. Or we could go 30, 25 plus 20. Well, that's a bit better than our other option. Is that the best option? What if we go Queenstown to Minortown to Underwood? So it's going to be 45 plus 20, which will give us 65, as opposed to the 30 plus 25 plus 20, so which would give us 10 extra. So no, certainly we'll go from Queenstown to Minortown to Underwood for a total weight of 65. And so we can say that it would take 65 minutes to travel from Queenstown to Underwood using the fastest route. Okay, question 24. A population P is to be modeled using the function P equals 2000 times by 1.2 to the power of T, where T is the time in years. So what is the initial population? So to figure out the initial population, all we need to do is set T equal to 0. And so what that'll give us is P equals 2000, and then times by 1.2 to the power of 0. And we should remember that anything to the power of 0 is just going to be 1. So our answer here is just P equals 2000. Alright, so moving on. Part B, find the population after 5 years. So all we need to do is set T equal to 5. So our population is going to be equal to 2000 times by 1.2 to the power of 5. Alright, and then quickly putting that into our calculator and making sure that we round this correctly, we'll get an answer of 4,977 people after 5 years. Alright, so part C. On the axes below, draw the graph of the population against time, showing the points at t equals 0 and t equals 5. So what we want to do is we want to quickly put in the initial population, and just remembering that since t is equal to 0, that means that that's going to be our y-intercept. So I'm going to go ahead and put 2000 over here, and that's obviously at 0 at the origin. All right, so then after 5 years, let's pop that down here. We'll have how many people? 4,977, so we might want to put that around here. So we'll say over here is 4,977. And so now we have our 2 different points, graphed, nice and easy to see. However, what we need to be aware of is what does this function look like? Because it is not a straight line, this is following an exponential. And we can see that because we have t in the power. So this should look very roughly like this. Anything along that line will get you the full marks. All right, moving on. Question 25. A rectangular sports ground has been drawn to scale on a 1 centimeter grid as shown. The scale used is 1 to 3,000. Alright, so Kerry took 12 minutes to walk around the perimeter of this sports ground. So what was Kerry's average speed in kilometers per hour? Alright, so first things first, what I would do is I'd count up quickly how long is this perimeter? So we have 1, 2, 3, 4, 5, 6, 7, 8 along the top, so I'm just going to go ahead and put 8 along the bottom as well, obviously, and then 5 on either side. So we know that if it's 1 centimeter each way round, then this will be 8 centimeters times 2, so 16, plus 10, so we'll have 26 centimeters. And what we need to do is now consider that it's in a ratio of 1 to 3,000. So what we can do is simply times 26 by 3,000, and let's see what answer we will get. So 26 times by 3,000, we'll get 78,000 centimeters. But clearly, writing it in centimeters isn't going to be very helpful when we want to find it in kilometers per hour. So first of all, how many centimeters are in a meter? There's 100. So what we'll do is just divide by 100, and then we can write this as 780 meters. And how many meters are in a kilometer? There's 1,000, so now we divide this by 1,000, and then we'll write this as 0.78 kilometers. Okay, so that's the total distance, and it took 12 minutes to go 0.78 kilometers. All right, so what does that mean in terms of making it into kilometers per hour? Well, how many lots of 12 minutes are in 1 hour? We can quickly see that that's going to be 5 times 12. So all we need to do is say 0.78 times by 5, and that will give us the final answer of 3.9 kilometers per hour. The other way to approach this, if you're not comfortable just by doing that very, very quickly, is to figure out how far you go in 1 minute. So we have 0.78 in 12 minutes. So what we could do is divide that by 12, and that will give us the distance covered in 1 minute, and then we could just times that by 60, and that would give you the exact same answer of 3.9 kilometers per hour. And that's our answer to question 25. Okay, moving on. Question 26. So, Nina plans to invest $35,000 for 1 year. She's offered 2 different investment options. Option A, interest is paid at 6% per annum, compounded monthly, and option B, interest is paid at R% per annum, simple interest. So, calculate the future value of Nina's investment after 1 year if she chooses option A. Okay, so just remembering our compound interest formula, which I'm going to go ahead and write it out like this. So A equals P times by 1 plus R over N, all to the power of NT. Now, I do this a little bit differently. So I'll say that T is the number of years, and N is the number of compounding periods per year. A little bit different to normal, but it should be fine. So, calculate the future value of Nina's investment after 1 year if she chooses option A. So it's 1 year, and it's compounded monthly. Okay, so if it's compounded monthly, then that means that N is going to be equal to 12. We know that's for 1 year, so T equals 1. We know that the principal amount invested, P, is equal to 35,000. And we know that the interest rate, R, is equal to 6%, or 0.06. So if we put all those different values into that formula there, we find that the future value, A, of Nina's investment is going to give us $37,158.72. Alright, so what to do now? We need to quickly look at the option B, where it says find the value of R in option B that would give Nina the same future value after 1 year as for option A. And we need to give that answer correct to 2 decimal places. So if it's simple interest, alright, so quickly looking at our simple interest formula, well, we know that our simple interest formula is normally just written out as I equals PRN, I believe, or PRT, depending on what you've learnt it as. Okay, so we know that the interest is going to be equal to the difference between this total amount and the 35,000. So clearly, the interest is going to be $37,158.72 minus 35,000. So we can say that I equals $2,158.72. So we also know the principal amount, and we know n, as n is just going to be 1. Alright, okay, so we'll fill that in, and we find that n equals 1, p equals 35,000, and then we'll substitute those values into our formula, and then we find that we have $2,158.72 equals 35,000 times by r times by 1. I'm not going to bother writing that in. And that will give us our formula here that we can now work with. So now dividing both sides by 35,000, we find that r, the interest rate, is going to be given by $2,158.72 divided through by $35,000. And what that gives us now is that r is going to be equal to 6.17. Just remembering that we needed to give it to 2 decimal places. And that's our answer to question 26. Okay, question 27. So the price and the power consumption of 2 different brands of televisions are shown. So we've got TV A and TV B. So the average cost for electricity is 25 cents per kilowatt hour. If a particular family watches an average of 3 hours of television per day, the annual cost of electricity for television A for this family is $48.18. Okay, so for this family, what is the difference in the annual cost of electricity between television A and television B? So for this question, we're actually going to go ahead and create almost a rates and ratios sort of problem. So we know that the power of TV B is 160, and if I divide that through by the power of television A, 176, I'll also find out the relationship between the 2 different amounts of money that each of them cost. So for TV B, we're going to call that X, and for TV A, we know that the yearly amount is $48.18. So now to figure out how much TV B would cost per year, all we need to do is times both sides by $48.18. And then we find that X is equal to $43.80. Okay, so now it does ask us what the difference between them is going to be. So our answer here is $48.18. Subtract $43.80, and that leaves us with a total difference of $4.38. And that's question A sorted. Okay, moving on to question B. Now asks us, for this family, how many years will it take for the total cost of buying and using television A to be equal to the total cost of buying and using television B? Okay, so what we need to consider here is realistically just the prices. That's all we're concerned with here. So we see that TV B is more expensive by $21.90. Well, how much electricity do you save with TV B in terms of the money? Well, you save $4.38 per year. So what we're going to do is we're just going to go ahead and divide that difference in the price by the savings per year of $4.38. And we find that that is equal to 5 years on the dot. And that's how long it would take them for it to be an equal cost. Alright, moving on to question 28. So, a salesperson is interested in the relationship between the number of bottles of lemonade sold per day and the number of hours of sunshine in the day. The diagram shows the dataset used in the investigation and the least squares method regression line. So, question A. Find the equation of the least squares regression line relating to the dataset. Okay, so what we want to do is we want to pick 2 points on the line. Alright, so I'm going to go ahead, I'm going to pick this point here, right at 0, 2. And then looking at this graph, the next best point would probably be maybe over here, where x is 5 and y is equal to 18. That looks like it's actually on that line and on that coordinate there. Alright, the important thing is here to not choose the individual points. Do not do that, okay? So find the equation of the line. So we need two things to construct an equation of a line in the form of y equals mx plus b. So the first thing is going to be our y-intercept. So clearly, it's going to be 2. So we'll note that down. So b equals 2. And now for our gradient, let's just use our gradient formula of m equals y2 minus y1 over x2 minus x1. Okay, so y2, let's say that this point over here is our second coordinate, so the y value of that is 18, and y1 has a y coordinate value of 2. Okay, and then x2, that is 5, and then x1 is simply 0. Okay, and then so we end up with 16 over 5, or we can rewrite that as 3.2 in decimal form, and that's our gradient. Okay, so now we know that m equals 3.2, so we can conclude that the equation of the least squares regression line relating to that data set is y equals 3.2x plus 2, and that's part A. Okay, part B. Suppose a sixth data point was collected on a day which had 10 hours of sunshine. On that day, 45 bottles of lemonade were sold. What would happen to the gradient found in part A? Okay, so if we try and find where that point would fall on this graph, well, we go to 10 hours of sunshine and we go up to here, and that's 32. So clearly this would be somewhere right up the top. So it's not really going to be, present on this graph. So what we can say is that it would actually increase the gradient. And it's fairly clear as to why that is, I believe. So mainly just because we're just adding another point really, really, really high up, and then the new line of best fit would kind of have to account for that. So we'll just say that it increases the gradient. Okay, moving on to question 29. So we have this problem here, so x plus x minus 1 over 2 equals 9. So first thing to do would probably be to multiply everything by 2, so as to get rid of that denominator there. So then we'll end up with 2x plus x minus 1 equals 18. Collect like terms, so 2x plus x equals 3x, and then we'll get rid of that minus 1 by adding it to both sides, and then we get 3x equals 19, and there we are at our last step now. Just divide by 3, and we find that x equals 19 over 3, and that's question 29, easy 2 marks. Alright, Ariana owns 1,500 shares in a company. The market price for each share is $27, and Ariana's total dividend from these shares is $810. So we need to calculate the dividend yield for her shares. Okay, so to calculate dividend yield, what you want to do is you want to figure out how much money does each share give you in terms of dividend, and then divide that by how much the actual share costs. Okay, so we have $810 coming in terms of dividends, but that's from 1,500 individual shares. So we find that individually, each share gives us a dividend of $0.54. Okay, so now to actually go through and calculate that dividend yield, it's just going to be, as I said earlier, equal to the amount of dividend per share divided by the price of the share. So we'll get 0.54 over, and it costs $27. And we'll times that by 100, so that way we can make sure that it's in percent. And we get a dividend yield of 2%. And that's our answer there. Okay, question 31. So, present value interest factors for an annuity of $1 for various interest rates are, and a number of periods n are given in the table below. So there's our table of information there. So a bank lends Martina $500,000 to purchase a home with interest charged at 1.5% per annum, compounding monthly. Okay, that's a bit important to note. She agrees to repay the loan by making equal monthly repayments over a 30-year period. Okay, so how much should the monthly repayment be in order to pay off the loan in 30 years? And we need to give our answer correct to the nearest cent. All right, so first of all, the big trick here was that they've given us a 1.5% per annum compounding monthly. So we do, in fact, need to change that rate. Otherwise, you might look at this and you might just be tempted to think, oh, there's a 15, that must be the column we're working with. And not quite the case here. So what we'd say is 0.015, just changing that, that percentage into a decimal, and then we'll divide through by 12, and then we find that that's just equal to 0.00125. And so now we can clearly see that we're going to be working in this second column here. All right, the next little step that we need to consider is how many interest periods actually went past. So 30 years, but we had 12 periods per year. So 12 times 30, that will leave us with 360. Okay, so now we know we're working in the second column and the third row, so that means we'll be using this number down the bottom here. And so keeping in mind that this is for $1, but here we're going to be making repayments, adding all the way up to $500,000. So to figure out a monthly repayment now, all we do is we take that borrowed amount of $500,000, and now we divide through by this amount that we've just found there of $289, just 289.75411. And then rounding that to the nearest cent, we find that the monthly repayment should be equal to $1,725.60, and that is to the nearest cent. Okay, question 32. All right, so lovely little bit of geometry here. So a right-angled triangle, XYZ, is cut from a semicircle with center O. The length of the diameter XZ is 16 centimeters, and the angle YXZ is 30 degrees, as shown on the diagram. So, part A, find the length of XY in centimeters. Correct 2 decimal places. All right, I'm going to go ahead and label that X. It's not very clear. I'll write that there. So we know that it's a right-angled triangle, so that makes it a lot easier for us. So we can use just standard SOHCAHTOA. So we do need to quickly adjust ourselves to the weird angle of this triangle though. So we're going to be using this angle, and so from this angle's perspective, where's the hypotenuse? It's over here. The opposite is this side here, and then the adjacent is this side here. So to figure out x, we need to use something that can tell us our adjacent, that also uses our hypotenuse. So using SOHCAHTOA, that just leaves us with cos. So now we can write that cos of 30 degrees is equal to the adjacent over hypotenuse, so x over 16. And then we can simply solve that for x by saying x equals 16 times by cos 30 degrees. And putting that through into our calculator, what we find is that x equals 13.86 centimeters. And now you might want to stop here and rewrite that as xy in centimeters. So just quickly change this part to xy. Although ordinarily, if your marker sees that you've done all of the correct working out and that you've labeled your diagram, you should be fine. All right, moving on to part B. So it says, hence, find the area of the shaded region in square centimeters, correct to 1 decimal place. Okay, so to find the area of the shaded region, well, first of all, we recognize that this larger shape is a semicircle. So the area of a semicircle is going to be given ordinarily as half pi r squared. So we'll go ahead and write that out. So half times pi times by our radius is 8. So 8, and that's squared. Okay, but now we're going to be subtracting the area of this triangle. So I'm going to go ahead and erase what we've drawn on there before. So the area of a triangle, let's not forget, that's normally given by half AB sine C, where C is the internal angle between side lengths A and B. So again, we can go through and write that out here. So, and it doesn't really matter which side is A or B, that's pretty free to choose, but what we do need to note is that this side here is, that angle there is going to be our angle C. So half times a, let's say a was the xy, so that would be times by 13.86. And then side length b would be the side xz, which was 16 centimeters. And then it's going to be times by sine of c, and c here is 30 degrees. Okay. All right, and so when we calculate that and we put that to the nearest decimal place, that gives us an area of 45.1, and let's not forget our units, centimeters squared. Okay, and there we are. So that's question 32. All right, moving on. Question 33. For a sample of 17 inland towns in Australia, the height above sea level, x meters, and the average maximum daily temperature, y degrees Celsius, were recorded. The graph shows the data as well as a regression line. So the equation of the regression line is y equals 29.2 minus 0.011x. The correlation coefficient here is minus 0.494. Okay. By using the equation of the regression line, predict the average maximum daily temperature in degrees Celsius for a town that is 540 meters above sea level. Give your answer correct to one decimal place. So some people might be tempted to just use your ruler here and try and find roughly where that would be, and you might get a decent, spot on the graph, but it's going to be much, much better for us to just substitute the value of x equals 540 into that equation there. So let's do that now. So then that will leave us with y equals 29.2 minus 0.011, and x is now 540. Okay, and when we compute that, we get a value of about 23.3, and it's in degrees Celsius. And there we go. So that's part A, part 1. Part A, part 2. The gradient of the regression line is minus 0.011. Interpret the value of this gradient in the given context. Okay, so the fact that this is worth 2 marks actually tells us that we need to be specific about what this means, not just in terms of the maths, but in terms of the real life scenario that we're examining here. So in particular, we are looking at how the average maximum daily temperature changes with the height above sea level. So what we might say here is we might say something along the lines of, for 1 meter increase in the height above sea level, the average maximum daily temperature, I'm just going to write temp, yep, close enough, will decrease by 0.011 degrees Celsius. Because now that's relating the maths and what the gradient actually means, and now it's relating it back to the real life interpretation of this data set here. Okay, moving on to question 33, part B. So now, the graph below shows the relationship between the latitude x, degrees south, and the average maximum daily temperature, y, degrees Celsius, for the same 17 towns, as well as a regression line. So we have a new equation for that regression line, and here the correlation coefficient is r equals minus 0.897. So another inland town in Australia is 540 meters above sea level. Its latitude is 28 degrees south. Which measurement, height above sea level or latitude, would be better to use to predict this town's average maximum daily temperature? And can we give a reason for our answer? Okay, so we need to pick height above sea level or latitude. So let's have a quick look at these two. Let's see what they look like. So we can see on this first graph here, the points are a little bit more scattered than when we look at this on the second graph. So what that actually relates to is our correlation coefficient. So for the first graph, we had a correlation coefficient of minus 0.494. And then for the second one, we had a correlation coefficient of minus 0.897. And so since that is a little bit, I suppose it's less than the previous correlation coefficient, that's actually going to be a more accurate example. So what I mean by that is that the absolute value, I should say, of the correlation coefficient for the second graph is greater than the absolute value of the correlation coefficient in the first graph. So that means that it's going to be more accurate. All right, and so for that reason, we would say that it's more appropriate to use latitude as a measurement to determine the average maximum daily temperature. All right, moving on. So, question 34. In a park, the only animals are goannas and emus. Let X be the number of goannas and Y be the number of emus. Okay. So the number of goannas plus the number of emus in the park is 31. So hence, X plus Y equals 31. Let's write that down. Okay, so each goanna has 4 legs and each emu has 2 legs. In total, the emus and goannas have 76 legs. So by writing another relevant equation and graphing both equations on the grid on the following page, find the number of goannas and the number of emus in the park. Alright, well, going off of this information here, that each goanna has 4 legs and each emu has 2 legs, in total the emus and goannas have 76 legs. What we can rewrite that as now is that 4 times x, so 4 times the number of goannas, plus 2 times the number of emus, is now going to be equal to 76. Okay, so what we can do here is we can then go through that and graph those up respectively. So from this first from this first equation, we can rewrite that now as y equals 31 minus x. So what we should do is we should find the y-intercept first. So when x equals 0, we find that we have 31. All right. And now we need to determine, well, where would the x-intercept be? Well, similarly, it's going to be over here at 31. And so what we could do is we could try our best without a ruler to draw a roughly straight line. Okay, so now for this other line over here, well, we see that everything is actually divisible by 2 on this second equation. So we can now rewrite that as 2x plus y equals 38. And rearranging that for y, we find that y equals 38 minus 2x. Okay, so here, y-intercept is now going to be 38. So 5, 6, 7, 8 up here. And where will our x-intercept now be? Well, now our x-intercept for this one is going to be when x equals 19, y will equal 0. So again, what we need to do now is try our best without a ruler here to draw up a straight line joining those 2 points. Obviously, in real exam conditions, you should be using your ruler to make the most of your, the equipment provided. Alright, so if we had used a ruler, well, we would actually find that the point in question is over here at around 7 and 24. So I've drawn it a little bit askew, but, that's alright. Let's pretend we used a ruler and then it all works out quite nicely. Look at that. Fantastic. There we are. You can barely even tell. Alright, moving on to question 35. Alright, and no, sorry, actually I should mention that the number of goannas here was 7, and the number of emus is 24. Okay, now moving on. 35. So a publisher sells a book for $10. At this price, 5,000 copies of the book will be sold, and the revenue raised will be 5,000 times by 10, so $50,000. The publisher is considering increasing the price of the book. For every dollar the price of the book is increased, the publisher will sell 50 fewer copies of the book. Alright, so if the publisher charges 10 plus X dollars for each book, a quadratic model for the revenue raised, R, from selling the books is given by that formula there. So a graph of this quadratic model for revenue is shown. A dashed line is used for values of X, which are not relevant to the practical context of this problem. Okay, so part A. By first finding a suitable value of X, find the price the publisher should charge for each book to maximize the revenue raised from sales of this book. Okay, so first thing we should actually do is just look at our problem and see, well, where is the highest revenue? So clearly the highest revenue is this point here, right smack bang in the middle of that parabola. So how do we find the point that is right on the middle of the parabola? Well, we know that we can use the formula. X equals minus b over 2a, and that actually tells us the axis of symmetry for any parabola. or what it tells us now is the coordinates of the lowest or the highest point of the parabola. And so if we put those values into our calculator, so where b is 4,500, then we have minus 4,500 divided through by 2 times a, and a is minus 50, so that's going to be by over minus 100. Okay, and so now chucking that into a calculator or just simply computing it, you find that x equals 45. So that means that this value here is going to be 45. And so that's the value of x that we need to take. But that's not quite the answer for this question, however, because we need to be very careful here. By first finding a suitable value of x, so we've done that, find the price the publisher should charge for each book to maximize the revenue raised from sales of the book. Now we're very, very close, but we need to refer back to this point up here, where it says the publisher charges 10 plus X dollars for each book. So that means that the price that they'll be selling it for is going to be 45 plus 10. So $55 for each book. Okay, part B. Find the value of the intercept of the parabola with the vertical axis. So this one's not too bad. All we need to do is, well, find our y-intercept. So that's done when we set x equal to 0. So we look back at this equation here. So if x is 0, then that goes away, and that goes away, and all that's left is r equals 50,000. So that's our answer there. So we can just say 50,000. Too easy. Okay, moving on. Question 36. So lovely network problem here. So a project requires completion of 11 tasks, A, B, C, all the way up to K. A network diagram for this project giving the completion time for each task in minutes is shown. Okay, so what we should probably do is we should probably go through and actually map out the earliest starting time and then do backward scanning to figure out the latest starting time for each individual task. So let's go ahead and we'll sort of draw this up in a nice little box everywhere. So we've got A, B, and then C over here, D over here, and hopefully you'd use a little bit more space in your actual HSC. I'm just going to go a little bit off to the side here. It should be fine though. F over here. H can fit in here. I, yep, should be right. Chuck it down there. We have J over here. And then we have K right up the end here. Okay, so more or less that's what your network should look like when you're preparing for the earliest start time, latest start time sort of manipulation of your network. So it says, find the minimum time to complete the project. Okay, so fantastic. All we need to do is we just need to go through and start seeing what the earliest start times can be. So for point A, well, the earliest is 0. For point B, the earliest is 0. Fantastic. Okay, now assuming that we continue with the earliest start times, let's just go through the A path first. So then for C, well, the earliest we could start that is 5, since that's how long it takes us to complete task A. Then to start task D, the earliest we could do that is 12. Again, 5 plus 7, that gives us 12 as the earliest start. Then for E, well, we're adding 2 more, since that's the duration of task D, so that would be 14. Oops, there we are. And we'll go back down to the bottom row here, bottom path, I should say. So now task F, what do we think about F? Well, earliest start time here, again, so it must happen after B, and that means that the earliest start time there is going to be 8. Okay, so now the particularly interesting one, I think, over here is when we start looking at G. So the reason for that is because G relies on 2 different paths for us to actually be able to start that task. So we must have completed BF, and we must also have completed ACDE. So which one of these is longer to get to this point here? So if we go BF, that takes 14 to get to that. But if we take ACDE, that takes 5, 7, 2, 3. So that actually takes us, I believe, 17 to get there. So that means that for us to start task G, we need to actually wait 17, I believe this is minutes. Okay, and so similarly for H, the earliest we can start that is going to be 17. Alright, now continuing through, so for J, so G took 5 minutes, so that means that J can start earliest at 22. For I, well, H takes 6, so that means we can start I at 23. And so that means now, well, for K, which one took longer? Well, I only took 3, so that means it would take us all the way up to 26 minutes to get from I to K. But to get from the starting point of J to the finish point of J just before we can start K, well, that actually takes 8 minutes. So that means that the earliest we can start task K is going to be 30. I'll make that a little bit bigger. There we are. So for us to actually finish, that means that the earliest we can finish is now going to be the 30 plus how long does K take? It takes us 10 minutes. And there we are. So that's our answer for the minimum time to complete the problem. It's 30 plus 10 equals 40. Now, it might seem like a lot of work has just gone into this, and we're not even halfway there yet. So let's quickly finish our backward scanning, and then we'll be able to pump out the rest of these problems. So, backward scanning, how does that work? Well, we start from the end, and we work our way backwards. Now trying to figure out when is the latest that we can start each task. So, for part K, well, clearly that's just by itself, so we want to try and finish this as soon as possible, so that also will have a latest starting time of 30 minutes. Okay, now we go back. Let's have a look at J. Well, 30 minus 8 gives us 22, so that stays the same. But now the 30 for the latest start time of K minus the 3 for the task duration of part I, that actually gives us 27. Okay, and so now looking at, let's say, H. So if we can, at the latest, start I at 27, and it takes us 6 minutes for H to be completed, then that means we can take H for the latest start time of 27 minus 6, so 21. All right, and now if we continue through, we'll see, fairly similar calculations. So G, we must start that at 17th minute, pretty much. And then going through for E, well, 17 minus 3, that's going to give us 14. And then as we continue through this top row, we see that all the numbers are actually the same as we go through, subtracting the latest start time of the previous one, remember in terms of backward scanning, from the actual task duration. So for part C, it's now 5, 5. And for A, it's 0, 0. Okay, so now for the lower path, well, what about part F? Well, for F, we can start at 8, but then, again, if we also started that at 11, it would actually be perfectly fine. Just remembering that we need to finish that by 17, so if it takes us 6 minutes, we can start it at the 11th minute, and then finish at the 17th minute to continue down this network here. All right, and then continuing on, we can also start B 3 minutes later, then we start A. There we are. So now we have the complete time managed network here. So let's go through and figure out the rest. So the critical path for this project, so that's going to be the path that we can't delay. So the path that we can't delay, we see goes from A to C, C to down to D, and then E, and then which one can't we delay? Well, it's the top path here. So G, J, K. And so it's a little bit tricky to try and follow that through the diagram. So what you should be doing to really showcase this critical path is just writing out the different vertices and path names. So it's A, C, D, E, G, J, K. Okay, and there we go. So part C, a new task X is to be added to the project. The earliest starting time for X is 17 minutes. The latest starting time for X is 18 minutes. And X has a completion time of 12 minutes. Okay, so we need to add task X to the given network diagram above and state the float time. I'm just going to go ahead and neaten up our network a little bit. Okay, so we know that it has the earliest starting time of 17 minutes. So where else on this graph, on this network, I should say, did we have an earliest starting time of 17 minutes? Well, that was for the junction between G and H. So what that tells us is that X should come off here. I'll attempt to draw it in there like that. And then we can see that X is a path going from this junction here through down to here. Okay, and there we go. So that's where X belongs. And we know that it takes 12 minutes. So we'll write that information in just like that. Okay, now the float time is given as the difference between the earliest starting time and the latest starting time. So they've pretty much just given us that answer there. So the earliest starting time was 17 minutes, the latest starting time is 18 minutes. Well, the difference between those is 1 minute. So we'll just quickly write float equals 1 minute. And there we go. So we finally finished question 36. I do believe this is the longest question in the entire exam. Reason for that is most of these network problems, unless it's a simple sort of network, minimal spanning tree problem, they will tend to be quite lengthy in nature. All right, finally, let's move on. Question 37. Okay, the diagram shows a triangle ABC, where AC equals 25, BC equals 16, and angle BAC is 28 degrees. And we know that angle ABC is obtuse. So we need to find the size of the obtuse angle, ABC, correct to the nearest degree. Okay, so we see that we've got opposite pairs here of angles that we're interested in. So what that tells us is that we would most likely be using the sine rule here. So the sine rule, let's write that out in terms of the variables given. So we can say that sine of ABC over, what's the opposite side length? Well, opposite of that is 25, and that's going to be equal to sine of 28 degrees divided through by 16. Okay, now to quickly solve for ABC, what we need to do is firstly multiply both sides by 25, but then we also, after that, need to take the inverse sine of both sides. And what that tells us is that ABC is going to be equal to sine inverse of 25 sine of 28 degrees divided through by 16. And we find that that equals out to around 47.18 degrees. Now, does that look right for this diagram? Not quite. And the reason for that is because this is an obtuse triangle, an obtuse angle that we're looking for here. So to determine what this actual angle is going to be, well, what we need to do is we just need to say 180 degrees minus that angle that we've just found. So 180 degrees minus, and we'll round that down to 47 degrees as we're only interested in the nearest degree. And we find that angle ABC is now going to be equal to 133 degrees. Okay, question 38, we're almost there, almost finished. So random variable is normally distributed with mean 0 and standard deviation 1. The table gives the probability that this random variable lies between 0 and z for different values of z. So that's just telling us the area, the shaded area, essentially. Alright, part A. Using the table, show that the probability that a value from a random variable that is normally distributed with mean 0 and standard deviation 1 is greater than 0.3 is equal to 0.3821. Okay, so what we need to consider here is a couple things. So first of all, we really need to make sure that we are aware of our empirical rule and the actual percentages represented throughout the standard distribution, or the normal curve, or the bell curve, or the Gaussian, as you might have heard it referred to. So we know that to the right of the mean is 50% of the data, and to the left of the mean is 50% of the data. So what we can do here is, well, we can use the information in this table to figure out the shaded region between z, when it's equal to 0.3, and 0, so that shaded region there, and then we subtract that from 50%. And that's how we'll work this problem out here. Okay, so for this problem now, well, we're going to be using this probability part here of probability of 0.1179 since z equals 0.3. Okay, and so we know that the entire area to the right of the mean is 50%, and then if I subtract just that tiny little shaded in area here, we're left with that section there. So to write this all in terms of decimals, well, we get the right-hand side of 0.5, and now we subtract that shaded area of 0.1179, and we find that that is equal to 0.3821, and that's what we're looking for. Okay, part B. Birth weights are normally distributed with a mean of 3,300 grams. So we'll go ahead and write that down. So mu equals 3,300 and a standard deviation of 570. Okay, so sigma equals 570. By first calculating a z-score, find out how many babies out of 1,000 born are expected to have a birth weight greater than 3,471. So we're going to go ahead and let x equal 3,471. And then we know according to our z-score formula that z is equal to x minus mu all over sigma. So just putting in that data now, we get 3,471 minus 3,300 and divide through by 570. And we find that the z-score is equal to 0.3. What's interesting? It's the same z-score that we're working with in part A. Okay, well the only difference now is that now we are looking at a percentage of 1,000 babies being born. So if it's going to be a heavier than 3,471, well we know the percentage is going to be equal to 38.21%. So all we'll do here is we'll say that 38.21% times by how many babies were born? 1,000, and that is the approximate probability, I should say the approximate number of children that are expected to have a birth weight greater than 3,471 grams. And obviously that is actually just equal to 382.1 babies being born. And so now in statistics, that's kind of like the only situation where you can ever actually have a 0.1 of a person, just because it's a statistical representation. So if we had times this by 10,000, or sorry, if we had it out of 10,000, then perhaps we would have 3,821 people. So we keep it as that decimal, so that way we can scale it in future circumstances. All right, question 39. Let's have a quick look at this one. So the diagram shows a compass radial survey of the field ABCD. So triangle COB has an area of 466 meters squared. So we need to find the size of the acute angle COB, correct to the nearest degree. Okay, so earlier we mentioned the area of a triangle, and that was given by the formula A equals 1/2 times AB sine C, where C, the angle, is the internal angle between two side lengths. And we find that all this information is given to us on this diagram here. So A, the area, or sorry, capital A, the area I should say, is 466, and then we have 1/2, and let's say A is 35, and then we can say B is the 28, and then we know that sine of C, whatever that angle might be, well we know it's represented by COB, and we can now rearrange this whole problem. And so when we do that, and we take the inverse sine of that problem, we find that the angle COB is equal to around 72 degrees to the nearest degree. Okay, and that's part A. So it's just a simple rearrangement of this problem here. All right, part B. So if a farmer wants to put a fence around the triangle DOC, let's quickly highlight that part. So it's DOC, that section there. Oops, I'll try and draw that a little bit more accurate. There we are. So DOC. Find the length of fencing required and give your answer in the nearest meter, in meters correct to one decimal place. All right, so what we need to do here is have a think about how we can figure out this side length DC. That's the only one that we're missing. We know CO and we know OD. So DC, well what we can do is we can probably try and use the cosine rule here. So the cosine rule, let's have a quick reminder, is given as c squared equals a squared plus b squared minus 2ab cos c. And now the only thing that we're missing here is this angle C, that internal angle between sides A and B. But we can figure that out because we figured out this angle earlier, COB, as 72 degrees. And we know that essentially the radial survey, remember to consider this like you do bearings, so you start at north and go all the way around until you hit that line. That gave us an angle of 330 degrees. So what we know is that it's now going to be equal to 330 degrees all the way around to this point. And what we can do is, well, we can just subtract all the little intermediate values. So the angle from here to here is 150, given by, again, the radial survey. And then we know the internal angle of COB was 72. So that means from the 330 degrees, we'll be subtracting 150 degrees and then subtracting 72 degrees. And that will leave us with the angle of DOC of about, I believe, 108 degrees. Okay, so now we know the angle, we know A and we know B, and now we just need to figure out C. So substituting all those values into this formula, and don't forget to take the square root of that entire right-hand side, we find that the side length DC is now going to be equal to about 47.76 meters. Okay, we're not quite finished yet because that just tells us the unknown side length, but to go through the whole problem again, we want to figure out the entire perimeter of the triangle DOC. So that means that we need to add all those different sides up. So now it's going to be 47.76 plus 31 plus 28. And so now to the nearest decimal place, we'll say that the total fencing is equal to 106.8 meters. And that's just after we've added all of those different lengths together. And there we go. Okay, second last question now. We're going pretty well. So, question 40. A table of future value interest factors for an annuity of $1 is shown. So, Simone deposits $1,000 into a savings account at the end of each year for 8 years. Okay, so right off the bat, we know that we're most likely interested in the number of periods being 8. The interest rate for these 8 years is 0.75% per annum, compounded annually. Okay, so now we know the interest rate that we're working with. So now we already know, before we even look at the actual question, that we'll be working with this column and row here. So after the 8th deposit, Simone stops making deposits but leaves the money in the savings account. The money in her savings account then earns interest at 1.25% per annum, compounding annually for a further 2 years. So we need to find the amount of money in Simone's savings account at the end of 10 years. Okay, so for the first 8 years, she had an interest rate of 0.75%. Okay, so we know we have that number there. So let's quickly write that out and see what does that mean. Well, if we had put $1 for 8 years at that interest rate, it would turn out to be $8.21.32, right? But now we've put in $1,000. So what we need to do is simply times that by 1,000. And so we get a value of $8,213.2 after the 8 years. Now it then says that for 2 more years, she just left her money there to accrue interest. She didn't make any more deposits. So what that means now is that we'll use our compound interest formula of A equals P outside of 1 plus R to the power of N. And let's see what we get. So, well, A, that's what we want to find out. P equals 8,213.2. 1 plus, well, what was the rate? 1.25%. So we'll write that as 0.0125. And how many years was it? It was 2 years. And so if we put that into our calculator, well, we get a value of A, the final amount, equal to $8,419.81. Okay, now to the last question. We've made it. So question 41. So in a particular city, the heights of adult females and the heights of adult males are each normally distributed. Information relating to two females from that city is given in Table 1. So here we are, we've got that table here with the height, the gender, and the percentage of females in the city shorter than this person. So the means and standard deviations of adult females and males in centimeters are given in Table 2. Okay, so again, similar sort of data. Now, a selected male is taller than 84% of the population of adult males in this city. So by first labeling the normal distribution curve below with the heights of the two females given in Table 1, calculate the height of the selected male in centimeters, correct to 2 decimal places. Okay, so the trick here is that we must 100% be confident with the empirical rule. Okay, if we've forgotten our empirical rule, we're going to find this very, very challenging. Fortunately, though, the empirical rule is written on your data sheet. So let's go through and quickly just write in mu, and then this would be mu plus sigma. So I actually might just make that plus sigma. This would be plus 2 sigma. I'll put minus sigma down here, and then minus 2 sigma over there. And that should be probably all we need actually noted on this graph. Now, what are these 2 points that they're talking about? Well, we can use this data and use that side by side with our empirical rule data, right? So let's just remind ourselves, what does the empirical rule say? It says that within 1 standard deviation of the mean, you have 68% of all data. Okay, so 68% of all of the data is within 1 standard deviation. So what does that mean? That means that if I was to quickly draw this out from here to here, we have 68%. What does that mean for the outsides? That means that there's 32% on the other 2 sections, but it's 2 different sections and they're the exact same size. So it means that this must be 16% and this must also be 16%. Aha, and that looks very familiar to something that we've seen above in our table. So what does that mean? That means that this minus sigma corresponds to this height of 160.6 centimeters. Now, what about for the 97.5? Well, going by similar sort of procedures, we get that the height of this person will actually be 2 standard deviations above our mean. So that height lies over here, and that is of 175 centimeters. Okay, so we're almost there now. So now we need to determine what is our mean. So our mean is going to be a common difference away from both of these. So it's 1 distance sigma away from 160.6 and 2 sigmas away from 175. So what we can do there is we can say, what's 175 minus 160.6? And then we'll divide that by 3. And that will give us sigma. So we find that sigma is equal to 4.8. Okay, so now if we know that mu is 1 sigma greater than 160.6, well, now we know that mu is equal to 160.6 plus 4.8, the sigma, which is now going to be equal to 165.4. Okay, so now let's continue. So if a selected male is taller than 84% of the population of adult males in this city, okay, so again, reminding ourselves, what's left of 84% from the 100? There's going to be 16%. So that means that this guy would fall right at the top of that first standard deviation. So that means that he is mu plus sigma. But let's not forget that he is a male, so we're going to be operating with this row of data. So that means that the height of this man is going to be equal to 1.05 mu, the mean, plus 1 standard deviation for the men, which is 1.1 sigma. Okay, and when we put that relevant data in, that's mu and that's sigma, we find that this man's height is going to be 178.95 centimeters, and that is correct to the 2 decimal places. And there we are. So that's the 2021 HSC paper. Hopefully you found this video somewhat useful, but whether you've just gone through particular questions that you found a bit challenging, or whether you sat through and watched the entire thing, hopefully you've learned something new. If you do have any questions, feel free to drop them down below. I'm sure I'll get around to answering them eventually. All these answers also can be found online through the HSC marking guidelines, although there's not really explanations given. It's sort of just, here's the answer, best of luck. So that's why I wanted to go through and provide the answers and a little bit of working out for all of these problems. Anyways, if you've liked the video, please leave a like and don't forget to subscribe for more content. Cheers.